Hello and welcome to Qt Pixel. Today I'm continuing my open source software development work, and today I'm working on a new project, an interpreter for a custom language that I'll be developing. And I see I have a few people in chat already. Hello Pixel Grief. Hello Arnie L. Foe. We're having a little bit of a discussion about the songs that I'm playing. And for those who didn't catch the last stream, I did get rid of the automatic song notification. If you are ever curious what a song is and want to learn more, you can always type in the song command to get a listing of what the song is and a link to my playlist. I start off my stream with my schedule today. Right now, I'm working on open source software development, an interpreter for a custom language. My next stream will be next Sunday, January 20th, again at 9 a.m. Project to be determined, probably continuing work on this interpreter as well. We'll see though, it depends on what I get to. I'm also wanting to get into game development, and so as I continue to learn Unity, I will start doing some Unity development as well. But that's still a little ways out. There's just a lot of things to go through for that. So this is the plan for today. This is a project that I've not started yet. I've done an interpreter before for a language before, a Lisp-like language before. But I want to kind of do a new one for something more procedural. Let's see. Oh, Chatter has given me a pronunciation guide on his name. I'm not sure how to pronounce it. That doesn't help. Because I see the ARNYLFO. I'm just not sure how to pronounce that. So if you can give me a better guide, I will do my best to pronounce that better. And my apologies for getting it wrong. Alright, so let me pull up my notes for this new project, the interpreter project. I don't have anything written down for it yet. I've not done any tasks. I have nothing scheduled for it yet. I think the first thing is to come up with a name. Part of the reason behind the name generator that we built. R like a pirate, Nillifo. R Nillifo. Okay, I get it now. I will pronounce it that way. Thank you very much. R Nillifo. Probably don't quite want the R like a pirate. Oh, that's actually from Pixel Grief. That may not be the correct pronunciation. If it's not correct, let me know. Arnilfo. Arnilfo. Okay, I will go with Arnilfo. Thank you for the correction. Alright, so we have our thing namer here. Let's go run this. Yeah, Arnilfo's out. This says that wasn't me. I wasn't paying attention. I didn't see who sent the message. I just saw the message, so my apologies. I sometimes glance over at chat without looking at it too closely. So we have our theme. Pixel Stacy is very helpful. We have our thing namer project. Let's go ahead and run this. And let's run the generator. Oops. And so we got this prints out, I don't know, 50 different names here, and we could just find one that looks really interesting. The reason why I don't really care about the name for this project is it's just going to be kind of a prototype. Nothing may come of it, so it might be exciting. Who knows? I just need something that to name it here. Intern Dyer. Well, I need someone to dye my interns. Coronary baker. Fleeting crypt. A noble sermon. Well, that's one that actually kind of makes sense. Yeah, there's still just a lot of words here that I just don't understand. An alert luncher. Well, let's see here. Let's just pick one of the ones that came out to me here. Like coronary baker is one possibility. Pixiker says the words are whack. Yeah, I'm not sure what's in these days with the kids. An alert luncher, that also caught my eye. Wasn't there a noble... I saw noble something earlier. Noble sermon. Intern Dyer, that was also a fun one. I think I like noble sermon. We'll go with that one. Ah, I cannot type. So as before, we'll initialize this with an nt-git repository and start to add in kind of the basic initial files. These would include like a readme. Let's actually go look over here and see what we want to copy over. Yeah, we want contributing and contributors, so let's copy those. We'll want a git ignore eventually, but not right away. We'll want a license. Palm, that is the Maven build file, so I'm going to hold off on that. I will want a readme. Source will do that when we do our initial kind of hello world. And thing namer, that is a file created by IntelliJ, so I'm going to ignore that. So let's start with what we got. Let's start to clean those up. A noble sermon. We'll start with the readme. And we just call this, what, interpreter or custom language. There's really nothing more specific to say yet. Once I have a little bit more in play, I can maybe include a little bit about the nature of the language and whatnot, but we'll keep it vague until we get there. We have no installation or usage yet, so we'll go drop that. Yeah, the contributing instructions will be the same. If you want to contribute, you go to our contributing page. Now let's go look at that. All contributors must sign and submit a contributor license agreement, CLA. Download the CLA, and I will simply give it the same name we've been using here, the Noble Sermon. Now, this file does not exist yet. I'll need to create that off stream because I don't have access to my website via this install. So that'll be there. Then let's go look up contributors. I think this is just vague and generic here. And license. Yeah, we just use the MIT license for this. I don't think anything has changed here. The year is correct. Yeah, that all looks good. I'll go ahead and commit this initial version. Let's see, I need to now create this inside GitHub. I don't need to do a new tab, I'll just do it here. User status. Now you can set a status message about what you're currently doing. Got it. Let's see, I'm going to steal the description from my channel title. And we need to push this. This will prompt me for my SSH key, which I got here. Now that should exist. Let's take a look. Excellent, so that all exists. Let's go look up the contributing documentation. And yeah, if we go here, this will give me a 404, because that does not exist yet. After this stream, I'll go fix that up so that that file does exist, and then we'll fix up this README file, or this file afterwards. I don't really anticipate anybody really wanting to contribute in them for the moment anyway, so I'm not too worried about it, but I'll want to go fix that up. And finally, for stream purposes, let's go add in a custom command so that if you want to have a link for this, you could do that. I'm doing this on my other window, or my other screen here. And now when you type in this command, the project command, into Stream, you will get a link to the project. Oh, it doesn't work yet? Oh, maybe there's a synchronization issue and it'll work after a few minutes. But I just made that change in their dashboard. So I'll maybe wait a bit and see if that works later. Okay, Okay, so we've completed our initial version. The next task is to create a hello world example. Really basic, but I like to start with this in all of my projects just so we have a kind of a template to work off of. Let's see, Arnilfo says we're asked will it be a compiled or interpreted language. It's actually going to be a little bit of both. What I'm going to be working on first is a interpreter. But what I want to do is have this be like a cross compiler so that I can convert this to like a Java app or a C# app or a JavaScript app or something. Something to kind of have your own custom language and then be able to port that as a library to any language of your choosing. The initial version will be an interpreter just because that's going to be easier, but then I will add in some compilation aspects down the road. And we'll see how far we get. This is mostly just kind of experiments and a prototype, so who knows how far we'll get, but that's kind of the long thought, is to add in those compilation aspects. Okay, so we need some directories here. Let's touch pom.xml. Or actually, let's just copy the pom.xml from our thing namer project. We can use that to start setting up our project model. Make dir, wow, I cannot type today. Make dir source. Main. Java. Com. I think this will be Qt Pixel. Yeah. We're just doing the project, the Java package naming scheme here. Then I think here we make the project name. Thing namer is what we have here. We're going to go Noble Sermon. And what did we do here? I think we had just our project or our classes in here. Yeah, so let's go ahead and touch main.java here. And this will give us kind of the starting point to start working on this. Noble Sermon. Let's go steal our description from here. Then we have the same copyright header, that never changes. Group ID is com Qt Pixel. Artifact ID is Noble Sermon. Packaging jar, we'll do 100 snapshot. And we'll copy over the URL from GitHub. Now these properties here, these are properties I take from all my projects. The source encoding tells Maven the encoding of the files I'm using, UTF-8, so it doesn't complain about that. Then I tell it my source is targeting 1.8, and I want my binaries to target Java 1.8. That way I can use Java 1.8 features. Although I understand there's newer versions of Java out there, I might want to switch to those at some point. The next step is to update our source file. Now let's actually steal some stuff from the generator of thing namer. Specifically, we'll want the copyright header and the package name. And let's go steal this from my POM file. Noble Sermon. And we'll just steal a little bit more here. We'll make this name, or main, I should say. We won't throw an exception yet. Okay, this should be enough to do the basics. Let's go see if I can compile that and run that. Excellent. Let's go copy and paste this command line so that I don't have to type that again. Dwayne Barry says, cool stuff, but the copyright in every file hurts me. Yeah, the issue with the copyright. Let's go actually look at the copyright here. Permission is granted free of charge to any person, blah, 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 blah. To deal without restriction, blah, 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 blah. The above copyright notice and this permission notice shall be included in all copies or substantial portions of the software. And so I've kind of interpreted this to mean that a source file is a substantial portion of the software. And so I tend to just put that everywhere. I tend to just ignore it after a while. But the thought is, if somebody wants to take a portion of this, a single source file or something, that the copyright does still apply to that individual source file. And I know it's a hassle. If I turned on the folding or outlining, I could hide it, but Dwayne Barry asks, could you put a license file in the app and get the same result? I'm not sure. I'm not an expert in copyright law, and I actually have put a license file in here. If we go to license.txt, this is what GitHub uses to recognize the license applied to this project. Oh my, there's a... This license needs to be updated. That's the wrong year. So I do have a license file, but the issue is if somebody takes one of the source files, but not the entire project, the copyright still applies to that source file. And so you really do want to put that license header in every single file. For something like, say, the GNU license, the GPL, I think they have a little tiny header you can put in the source file, and then along with a much larger license file you can put in the project itself. I'm not sure of how to do it with the MIT license. This is how I tend to do it, is just splat that copyright everywhere so that even if someone takes just one file, that they know that that license still applies to that one file. All right, let's go take a look here. So we've added our pom.xml, we've added a target. Let's copy over the git ignore from thing namer. And this will probably kill you as well, that I also put a copyright notice on the git ignore file. Let's close all this. Wish the get ignore isn't all that important, but still, I like to make sure that that notice is everywhere. Now, in this case, we're only going to ignore the target, because that is the only directory that is generated by Maven for the moment. Let's go take a look. Alright, so we've got get ignore, we have the POM, we have the source folder, and source has just main.java. That's the only thing it does is hello world. Very basic, but this gives me a starting point to build more elaborate code off of. And once I get this working, I'll then be able to switch over to a real Java IDE, and that'll make this a lot easier. Okay, I'm gonna go steal a commit message from thing namer. Add hello world example. So we're adding get ignore, POM, and the main.java. Now, see, I forgot to re-clone this repository, so I still need to give it the URL each time. And since we now have a bunch of stuff that exists, I'm going to go delete and re-clone this project. This way my upstream links will be maintained. I don't want to have to manually do that. See, Dwayne Berry says you could do git add origin URL instead of having to provide it each time. Or git remote add origin. Yeah, I was aware you could add that stuff. I wasn't aware of exactly how to do it. My preference is usually just re-clone, even though it is kind of heavy-handed. But it does mean I get what I need and I don't have to worry too hard about it. So now if I do git pull or push, all that stuff is hooked up. Okay, I also saw there's an issue with the license. So let's go look up the license and make a change to that here. Huh, this one's correct. Where did I see a broken license? Oh, this one's off, but this is a project from last year, so that's we'll ignore that. Yeah, I don't know where I saw that license. I may have opened up the wrong one, but the license is obviously correct. 2019. Sweet. Okay, let's go over to IntelliJ and open up a project. Now there it is. We got our code inside our editor now, or our IDE, so that'll make things a lot easier. This has unfortunately added a couple of IntelliJ files and directories, so let's go ahead and fix that. We've got .idea and noblesturman.iml. And we found that last time those were just added by IntelliJ, or the IntelliJ IDEA compiler. Or I should say IDE. So I'll grab .idea. And what was the other one? It was, I think, noblesermon.iml. That's kind of a project-specific file. Sweet, nice and simple. We've got another commit I could steal here. Ignore IntelliJ files. Alright, so that initial version has been committed to GitHub. Let's go take a look, see if my project command is working properly now. Still not working. What am I missing here? Do I need to... Just looking at my Streamlabs dashboard to see what I'm missing. It all exists inside my dashboard, but the command is just not working. I don't know, guess I'll have to ignore that and see if that ever gets fixed. I'll poke that off stream and see what I can do about that. But if you want the URL, this is the URL here. Alright, so we have the bare bones of our project now. We have something that basically says hello world. We need to start thinking through what is going to happen with this project. Since we're building a interpreter, we basically want kind of a read, process, print loop. Let's do like a main loop. Say read from standard in, process what is typed, print out the results. That's going to be the basic loop of an interpreter. Now we're obviously a long ways away from doing that, but we can start to build in kind of the basic loop to, probably the most basic thing is to read from standard in, and then just print out exactly what was typed in standard, and we could slowly begin to build on that loop. So let's start with that. I'll keep the hello world here for now until we have something more elaborate working. So we want to do like, it's a buffered reader, I think. I need to remind myself of the Java API for these things. We have buffered input stream, buffered reader. Yeah, so we want a buffered reader. And this takes a reader, and so I think we have an input stream reader, so we could say buffered reader is equal to new buffered reader, new input stream reader from system.in. And we'll read a line. While line is not null, the readLine function will return null when there is no more lines. While line is not null, we'll do something. Let's say system.out print line. And we're throwing a couple of exceptions here. I'm assuming these are IO exceptions. Yeah. So I'm just going to throw exception. Not a very good exception handling approach, but simple. And since I don't really care about this project yet, I think just going with kind of simple stuff for now. We can always add in more elaborate exception handling later when we care about it. Let's give this a try. So it basically just outputs the things that you type in. Just very, very basic. Then hit Control D to end the input stream, and that ends the program. So some other things we could do here is to say, print out the project name. Welcome to a Noble Sermon. And then if we wanted to, we could do like a basic prompt. Let's go look at, yeah, let's do like a simple prompt here. So this way, what you type in and what it prints out is going to look a little bit distinct. So we have welcome to a Noble Sermon. We can say hello. And it prints out hello. Goodbye. So just the very basics of our interpreter loop. It doesn't actually do any interpretation yet, but it does read from standard in and print out the results. And we can begin to build on that to add in more interpretation logic. See, sometimes I add a little more to my commit messages than I need to. We add logic to read lines from blah, blah, blah. Well, we could just say, read lines from standard in and write them to standard out. I just touched that source file, so let's go add that and commit that. Okay, so we have this first part and this second part working more or less. The obviously tricky part is to process what is typed. We need to actually we need to start kind of thinking about what our language is going to look like and start adding in ways of parsing that and whatnot. And so the approach I like to take is kind of a two-tier approach to parsing. Let's kind of come up with a very simple expression that our project might be able to support here. You know, like 2 plus 2 is probably the maybe the initial target expression. And that result should be, obviously, 4. So I need to think through, I'll actually make this a little bit harder. Let's say 12 plus, 30. Result should be 42 at that point. Just so we have like a multi-character number to deal with. So what we need to be doing is we need to recognize numbers. We need to recognize the plus sign and recognize more numbers, and we need to recognize that white space, you know, this white space here and this white space here, is kind of a delineator. And so what I've done before is I start building a tokenizer that looks for various things. We can have various states. We have like initial state. We have process in a number state. We have all sorts of different states. So let's just start thinking through what we want that to look like. Now let's go ahead and make a tokenize function. Say private static void I don't know, I want to call it line, but we'll say string S for now because I don't have anything more elaborate to put to it. I just got to think it through a little bit here, so I'll take a moment. We basically want to iterate over this string. So I could probably get what s.char at something, char at an index. So we can say int index is equal to 0, int state say 0 is our initial state there. And so I'll probably want to do a switch here. So switch on state. I say case 0 will do something. And while default will be illegal state exception, unrecognized. Doesn't like my spelling of unrecognized. Unrecognized. There we go. I'll probably want a while loop here, but we'll start with just the first pass here. We'll say char c is equal to s.char at index. So let's see, let's say if C is equal to now, if I remember correctly, Java gives me some ability to check things like digit. Oh, let's close this. Let's actually bring up the Java API, because I basically want to ask Java, is this like a digit? I want to ignore all these fields here. Who cares about all those? Char count, char value. I have a question here. Please, do you think you can help me with my installation of Ubuntu? I already have a bootable drive with Ubuntu menu installation. But when I partition my Mac for dual boot MS-DOS for Ubuntu and I boot into Ubuntu, it doesn't detect my hard drives, only my USB. Oh, that is kind of beyond my knowledge of Ubuntu. Yeah, I'm sorry, I'm not sure how to even begin that. I'm just not very familiar with Mac computers and Ubuntu that much. Someone in chat might be able to help you, or you might be able to find some help somewhere else, but unfortunately I'm not knowledgeable enough. Yeah, sorry about that. Alright, so we have is alphabetic. That's certainly one thing we could use for alphabet characters. Is digit. Is digit will take either a character or a code point. Oh, I wonder what char@ returns for us here. Let's actually go look at string and see what char@ does. Because I remember there were, when I did this project before, I remember I took some effort to support Unicode. And it might be handy to be able to support Unicode. Yeah, so we have char@ and then we have code point at. Then Arnulfo says, I think that's solved on ArchWiki's page on installation on Apple devices. Excellent. We got some smart people in chat, so go ahead and take a look at that, see if that helps you with your installation issue. And yeah, I think I want to do code point at rather than char@. Just so that we can ensure we support Unicode. It's probably not that important yet, but I found beforehand it was kind of interesting to be able to create a custom language that recognized Unicode and you're able to do special identifiers in Unicode. I probably wouldn't do that in a normal language just because it's a pain in the butt to try to copy or to type in Unicode characters. But for personal entertainment, it's great. So yeah, instead of char, we'll say int, say code point. And if, well, let's see, we had something to use here. I think it was character.is digit. Yeah, so let's give that a try. We'll say if character dot is digit. Not sure what to do with this yet. And we'll say digit. Else. Unknown character. And let's actually tokenize this. Let's say main.tokenize line. So it's not going to do much of anything yet, but it's going to start to show us kind of what's going on here. Let's go give that a try. Alright, so if I type in a word, just say unknown character and spit out hello. If I type in a number, say 12, it says it's a digit. Now I could go crazy. Unicode characters. Let's see if I could come up with a Unicode character table. Yeah, see if I can find a better one. I want to find like digits. We have ASCII digits. Yeah, so there's something like this, superscript 2, superscript 3, that could be a digit. Cherokee, wow. We got like the interrobang. So we've got number forms. Like I could potentially do like this is probably a digit. Let's give that a try. Unknown character, okay. If I remember correctly, some of these do show up as digits. Oh yeah, like this. I bet this shows up as a digit. Unknown character. Ah, boo. Let's go look this up again here. So we have the ISO Latin 1 digit, 0 through 9. We have Arabic Indic digits. Let's see if we can find Arabic Indic. Arabic digit 0, Arabic digit 1. Let's try Arabic digit 1 and see what that does. It comes up as a digit. So that is the interesting point of using the is digit rather than hard code on my own. I could always do a hard code of if the character point is less than a certain amount or greater than a certain amount, do it myself, or I could use is digit, and that does allow for Unicode forms of digits to show up as well, which could be a little weird, but we will see. See, I'm going to keep this open because I want to see if this will work for the next step here. So kind of the next step is to start building up the token we want to process. So right now we've looked at the first character. We start out in the state of 0, so no state or the initial state. And we go, is it a digit? Yes, it's a digit. Let's go print out that we found a digit. Others will print out unknown character. And so what we want to do is begin to build up the token . I think we want to throw this into a loop at this point. Let's say while index is less than s.length. And let's throw an unrecognized character here. Oh, helps if I add a throw here. And a new. Let's just see what this does for the moment. Let's close that. Right. Now let's break. I'm not quite prepared to finish that loop yet. Unrecognized character 102. It'd be nice if we could print out the actual character, but this is just kind of debugging right now, so I'm not going to worry too much about it. Yeah, so if it's a digit, let's go print out that it's a digit. Now let's increment our index. And go see what that does. Yeah, so now it detects 3 digits, so that it prints out the digit at the end. Then I'm going to go 1, 2, 3, followed by an A. And print out the 4 digits, and then the unrecognized character A. I wonder if I could do character.say toString. Let's go look at the character class here. See, toString takes a character, but not a code point. I want something that takes a code point. Interesting, this turns into a digit. I could potentially use that for tokenizing strings or integers. Also, get a numeric value. Here's a white space. We can use that to determine to filter out white space later on. Two characters converts the to a char array. We could try that. Two chars. Let's see what that does. Yes, I've just printed out an array, so I think it's just printed out a pointer at that point. Let's keep looking, see if there's any other options. Two characters. Aqua XV asks, any particular reason you run the program in the terminal rather than inside IntelliJ? Mostly habit at this point. I am aware that I can run it in IntelliJ. I just have gotten in the habit of running it from the command line. But should probably try it in the editor or in IntelliJ. That'll probably be faster. Let's see if Java code point to string. See if there's anyone else who's solved this problem. This is frustrating. You're given the most complete answer, but it is in the wrong language. I think for now I'm going to ignore this. Let's just go back to what we had before. We'll just print out the code point. Hello, thank you for the follow. I do appreciate that. And we'll fix that up when I have a chance. Yeah, to run this in IntelliJ, I think it's what, Control F10? Control Shift F10? There we go. So that does work. And so yeah, since this is just the starting point, I want to actually do a state change here. We'll say state is equal to 1, and we'll say 1 is tokenizing a number. Now we'll just say number. And so what will happen now, we run this, and we give it a number, it should complain about an illegal state. I don't like how it doesn't put my focus in that window. As I recognize the first digit as a digit, switches the state to 1, but then doesn't do anything. Alright, so now we go, is it a digit? We continue to process the digit. Else, when we're done, we go back to state is equal to 0. So we say we're done processing the digit, or the number in this case. Let's create a string. We'll say string is equal to empty, string token. So I wonder if string will allow us to append char points. Code points. Let's just do another search on code point and see what we can do here. Got code point at, code point before. We have char sequence. I wonder if char sequence could be used to create This is really an interface, not a class. I just need some way of converting this code point back to a string. I'm just not seeing an easy way of doing that. Now we go back to the beginning. Well, let's try something else. Let's say int array token is equal to, now I can't dynamically add things to an array. Let's just start trying something here. Let's say private static string code point to string. We'll say int array code point is equal to I need to do this. Return new string. And let's see, this says offset. We'll say offset is 0. And count we'll say is 1. We'll see if that's enough to do it. Twiz 1996 is hi. I'd like to know more about your project. Have you already defined stuff like grammar and syntax constructions? Or are you trying to build a generic interpreter? I've not built up a specific grammar and syntax yet. I'm mostly just starting with basic tokenizing, parsing. I have kind of in my mind where I want to go. I've done like a Lisp-based version of this before, where I'm doing constructions like plus 1, 2, and that would print out 3. What I'm trying to do is more of a procedural approach, maybe like similar to like JavaScript, where you're going to have constructions that look more like this up here, 12 plus 3, and you have stuff like int a is equal to 5, int b is equal to 12, and then be able to do stuff like a plus b. Then be able to define functions. In terms of how that will all look like, I'm not really sure yet. I'm just kind of starting with basic parsing and whatnot right now, and as I build up more of a parser, I can add and remove stuff as I see fit. But it's mostly just an experiment to see, to see what this looks like and how to do it, and some of the issues involved. This may not ever actually go anywhere. It's mostly just, just kind of messing around a little bit. But that's kind of a thought. This is maybe a more elaborate construction that I might be working towards. Whereas the current target is able to do something like this, to do 12 plus 30 and then print out 42 is kind of the current goal. Alright, so we've built up our code point to string. Let's see if I can do something with this. I think I have some errors printed out somewhere. Wow, this went nutso here. I was looking for a code point I can use to test this function I've just built. Okay. I think I could just test this. I can run this. Say A should give me what I'm looking for here. Yeah, unrecognized character 97. Let's give this a test. Let's say main code point to string, and we'll give it 97 and see if that works. Keep wanting to run this from the command line. Okay, excellent. So we've got code point to string for A, works just fine. Now let's test something more elaborate. Unicode smileys. I know that these are pretty elaborate. And I found these break a lot of things here. So let's go try this initial basic smiley face here. Unrecognized character 128512. That's the code point for the smiley face. And excellent, that does indeed work. So let's go bring this down to our air handler here. Let's do some simple wrapping. Yeah, that should work. Unrecognized character A. Excellent. This feels like a huge kludge to have to convert that to an array and then do the string conversion, but it works, and we can always revisit that later on when we find a better way of handling this. And so yeah, what I want to do is say string token is equal to the empty string. Then as we're processing digits, let's say token plus equals main dot code point to string code point. So we're just going to slowly build up the code point, or the token here. And then when we're done, we will print out the token. Now let's also add a break here. So what should happen is if I type in 123, it should recognize the entirety of 123. I hope we still have an issue. Princess Rika asks you too, what's the language like? Well, basically, working towards kind of a procedural language. You'll look something basically like this. We might have functions. I'm not sure how functions will look like yet. Probably a JavaScript style function. We'll say like, I don't know, square. And return value times value. Let's see, we could do, say, square of A plus square. So it's kind of a basic example of what a more elaborate construct might appear. We have a function defined, function calls, kind of going with a JavaScript style for that, but I'm doing strongly typed. So we have integers defined rather than untyped variables. Just kind of something I'm thinking of. You know, it's nothing really elaborate, mostly just getting experience with writing interpreters and compilers. Twas 1996 is all I see. It sounds great. I just answered because I have to work on a similar project in my school and have memories. Yeah, I actually did take a translator's course as part of my work at school where we built a compiler for a language. I don't think it was a custom language. I think they gave us a specific language. And they gave us some tools to help with it. I think Lex and Yak were available, or maybe not. I forget. But kind of redoing some of that work and just kind of experimenting with what it would take to build a custom language and an interpreter. And kind of my hope is to actually take this interpreter and compiler and then rewrite it inside the custom language. And so eventually the custom language would be changed to make it easier to write that interpreter / compiler. Then my secondary hope would be to make the compiler be able to target different languages. So like if I want to build a bit of logic and I want it available in Java, I can compile it to Java. If I want it to be a C# library, I can compile it to a C# library. If I want JavaScript or whatever, the ability to basically take something written in a generic language and then import that into any other language of your choice. Because right now, if I build a Java library, it's available in Java, but I can't really access that in, say, C# without going and rewriting the whole thing. So this is kind of an experiment to see if there's an approach we could take for being able to convert one language into another and have that be relatively easy. Might not be the right word, but possible. So that's kind of the longer-term thought there. So we have a bug in that we don't increment our index at all here. So let's go ahead and increment our index. And see what this does. Excellent. So we detect the first digit, we switch our state, we have 3 digits, and we print out our token as 1, 2, 3. And of course, the last thing I need to do is convert that to a number, or an integer in this case. Let's go print it. Let's go delete a couple things here. Let's delete that output and that output. We'll keep that for now. Well, let's also get rid of this this test line I put up here. Yep, we don't need that. We've got that working. So let's just give this a test. Process main is run. Oops. All right. I forgot that I left my project running. Princess Rika, I have memories. That course was bad. Now I've bashed out a couple little interpreters. While and that SOLang with the vulgar name that everyone knows. And I'm having to go and implement a stack-based concatenative thingy like forth. About accessing code, how about FFIs? Those are always fun. I'm not familiar with FFIs. Alright, what we should do here is print out integer. And just to do the parsing, let's say integer dot parse, I think. Parse int. So this way, if I do something huge, it'll probably fail. Let's see. Oh, that worked. That seems like it's way beyond what an integer should be able to use. Something seems weird here. I'll think about that. Princess Rika says, foreign function interfaces used for accessing compiled code from other languages, mostly C, really. I figured you tried that route and found it unpleasant, as many have. Well, I know, like, Java has ways of accessing, like, C. There's, I think, the native keyword. I forget how it works in Java, but I know that is an option for Java. And it's a pain, because you basically have to rewrite your C code on every single platform you want to run it on. And so my hope is to build a kind of platform-agnostic bit of code and be able to run that, not necessarily on any platform, but any language system. Now, there's probably people who already do this in different places. Oh, I see what's happening here. This is not printing this out. It's printing out what I typed in. Let's try this again here. 1, 2, 3. A. We got an integer 1, 2, 3 followed by a crash. Return null pointer says should have used Grawl. Not from Earth Grawl either. And again, mostly this is just for my own kind of education and not really necessarily something that will turn into a real project. So the fact that there are better approaches is not something I'm too worried about. If I do want to do a real approach, I'll probably do a much more thorough analysis and see what tools are out there and use those. This is mostly just for my entertainment and learning. Yeah, so the bug I'm looking at here is if I do 1, 2, 3 followed by A, we get integer 1, 2, 3 followed by the error. But if I do just 1, 2, 3 by itself, we just get our output code up here. But we don't actually process that integer. So the problem I was having is I type in a really large integer that should overflow the Java integer. That doesn't actually cause an overflow because we're not actually processing it. What's happening is we break out of this loop here. Let me minimize this. We break out of this loop before we hit this else. So let's see. What I want to do is probably do like less than equal to length, and now we need to handle the case in each of these cases where we're at the end of our string. So if we're at our start state, and we say if index is equal to s.length, we could just do a break. Let's see, we want to... The break is going to break the switch. What I want to do is break the while. For now, we can just do a return. It doesn't really matter. And now, if it's a digit, if it's a digit, we do. Oh wait, we actually have. This isn't going to work because we have the problem here. Oh, what we could do is do a bit of logic at the end here, and say, do another switch on state. I don't like this because this is going to duplicate some code here. Which this is probably just complaining about that. Found duplicate code, yeah. So case 0, we don't care. Case 1. We'll just do that. And break. We can probably make this even simpler. Now, another approach I could take to this would be to maybe add in a bit of white space to the end of the string we're processing. I'll think about that. This will handle it for now, I think. Let's give this a try. So 1, 2, 3 by itself. String index out of range 3. Oh, probably because I did not fix this. Alright, so now we have our processing of the token, the 123 integer token. Now we have the output. Now what happens if I give it a really lengthy integer? Number format exception. So this brings up the whole question of error handling. You know, if someone types in an integer that is beyond Java's ability to parse it, how do I want to handle that? And I think my thought for now is to just ignore it. That I'm not really going to care. We'll eventually want to add in more elaborate error handling. But for the current process, I think we can ignore that. So let's take a look. We've got 1, 2, 3 is handled. 1, 2, 3A. It gives us the number followed by an exception because we don't recognize the A. We also don't handle white space, so we do 1, 2, 3 unrecognized character white space. That indicates we probably want to put in some delimiters around this character. Like single quotes. So 1, 2, 3 space 1, 2, 3. Now I have unrecognized character space. Run it again. 1, 2, 3 D. Unrecognized character D. And now I want to test to do the Arabic conversion. So let's come up with 1. Oops. Yeah. So we got 1, 2, 3. Let's go see what this does. I was wondering if that would work. I was wondering if the integer.parseInt would recognize Arabic, and it does. That's fantastic. So I don't have to do anything on that. And if I do anything more elaborate, I'm sure that would work as well. So the only other thing I could think of to add here is, it would be nice if we had white space detection working. So go to 1, 2, 3 and have that be recognized as 3 different tokens. So I think for state 0, you could say if let's say if it's white space on code point, you do something. We want to stay in our current state, and then we want to increment our index. So that we could just say index plus plus. Ignore white space. Else, if it's a digit, to do this. Well, yeah, we can make this a one-liner. So I should be able to go 1, 2, 3, 4, 5, 6. Ah, okay. So it this highlights a bug in that we don't properly clear out the token when we're done processing it. So I probably want to say token is equal to empty string here. Just got to replicate what we do at the beginning. We set state to 0, we set the token to the empty string. Yeah, stop and run. Why not? I'll try this again. 1, 2, 3, 4, 5, 6. Excellent. So we process, we tokenize our 2 number tokens. We have 1, 2, 3, 4, 5, 6. We then print out the line at the very end. We're not actually doing anything with these yet. We're not putting these into a data structure. But that'll kind of be the next step. And Princess Rika asks, parsing from scratch too? Yes, we are parsing from scratch. We're building a custom tokenizer. We'll then build a custom parser once we're to that point. Because the idea is to hopefully have kind of a platform-independent interpreter and parser. But we'll see how far we get. Okay, I think we've got a pretty good commit point here. We can parse numbers. Let's actually stick with integers here. We'll have to think through what to do with the parsed results, but I think it's something we can ignore for the moment. IntelliJ has given me a couple of errors here, or at least warnings. Let's see what these warnings are. String concatenation plus equals in loop. Oh, come on. It's usually preferable to replace it with explicit calls to string builder.append or string buffer.append. Yeah, that's a good call. We might have some pretty lengthy tokens here. Let's go look up string builder, string buffer. I remember one of them is a multi-thread safe, the other is not. This must be java.util would be my guess. We have a string tokenizer. Huh. Doo-doo-doo. Or maybe it's java.lang. Ah, here it is. Yeah, string builder or string buffer. Yeah, string builder has no guarantee of synchronization, so we'll start with a string builder. So say token.append. Yes, I wonder what append does here with an integer. I'm guessing it's not a code point. No. I wonder if there's a code point aspect here anywhere. Ooh, append code point. Ooh la la. Well, that's pretty cool. Let's do that. We'll say append code point. And then what we need to do is say token.toString here. I think what token.clear would be my guess, or empty, or bleh. We have lots of appends, capacity, delete, insert, reverse. Oh, so we could delete, or we could just create a new one. Let's go ahead and create a new one. Now this gives us an interesting idea here for rewriting our code point to string. Let's see here. String builder s is equal to actually, let's just call this builder. We still need this because we still have the case of what is it? Here. Yeah, for our unrecognized character exception, we still need to convert that to a string. And so we have one more compiler error. Let's go look at this. Now we have one bit of duplicate code here. I think I have a solution to fix that, but let's continue to look through kind of these IntelliJ warnings here. Switch statement has too few case labels. One, it should probably be replaced with an if. Probably my final. Yeah, I bet it's complaining about this here. Yeah, so let's look at this. Let's go run our code and see what it's doing right now. Princess Rika offers fire for use on duplicate code. Yes, kill it with fire. Yeah, so the issue is if I get rid of this block of code, let's just make that go away for a moment. We don't process the integer at the very end. So we can see we get the first integer but not the last integer. What's happening is this loop is breaking out here and not doing the final processing of the integer, or we're not doing the processing of the final integer. And so what we could do is say s plus equals a space. How do I switch to the end to allow us to handle closing tokens? And then we can drop this entirely. And I think that'll be preferable. Whether there's a better way to handle this, yeah, I don't know. Where's my mouse? There it is. Excellent. So we've added a space to the end, and that allows us to process the 6789 token at the very end. And I think there are no more errors here. I think there's a typo found. Let's go see what that is. That's probably... yeah, it doesn't look the word non-infringement. And we're out of warnings. Excellent. Just go see where we're at. We haven't committed for a little while. Yeah, so we've taken a first stab at a tokenizer. We've added a call to our tokenize function right before we print out the line. We've added our tokenize function with our little white space hack to ensure we handle closing tokens. Initialize index to 0. We have our state descriptions. Initialize state to 0, initialize our token. Now then, while we have characters in our string, we get the code point. We do lots of things depending on our current state. Case 0 is initial state. Case 1 is we're processing an integer. And default is we don't recognize our state. This is kind of a developer debugging thing if I ever add in a new state without handling it or set the state improperly. For a starting state, we do things like we check for white space. If it's a white space, we ignore it. We just increment our index and do nothing else. Otherwise, if it's a digit, we set our state to 1. Again, this is we're processing an integer. Otherwise, we don't recognize the character. And I think we tested that. Let's go test that again here just to see. And we have 1, 2, 3, 4, 5, 6, and then A. We get 1, 2, 3, 4, 5, 6, but we don't know how to deal with A yet. So we just err out there. For case 1, if we are processing an integer, we check again to see if it is a digit. If it is, we append that to our token and we increment our index and then stay on the current state. So we keep processing integers until we encounter something that is not an integer. When we do, we print out the current integer, we reset our state to 0, and then we also reset our token. Let me change our documentation or our comments just a little bit here. I don't think I wanted to describe states here. Let's describe them here. No current token. Oh, come on. I don't like editors that try to be too smart and make it hard to type things. And here would be, well, we don't need to. Unrecognized state. Princess Rika says, that does get annoying, yeah. That's one thing I don't like about more advanced IDEs is they keep trying to do more stuff for you. And the stuff they do that works great is fantastic. But some stuff is just really annoying. Exactly. Princess Rika says, no, I just wanted an open bracket. I'll put the other one in later. Yes. The editor's like, no, you really wanted the closing bracket right here. And oh, by the way, you wanted me to automatically indent all of your code. And I'm like, no. Yeah, this still looks like it's working just fine here. Let's see, I think we can clean up this a little bit more here. Just get rid of kind of excess line breaks where they're not needed. Actually, we'll do that. Initialize our starting state. Let's see, iterate. Iterate through every character in the string. Every character in the string. I think that's a good amount of commenting. I don't like to over-comment, but I think having just a basic description of what each block is doing, particularly for something like this is kind of a specialized case, and if we didn't know why we were doing this, it wouldn't be obvious. So that's why I add that more detailed comment there. Otherwise, this is kind of more generic. And that's just our starting state, iterate through every character. Everything else is kind of more or less obvious. And it still seems to be working. Alright, so just go through this again. We've got our add white space, initialize our starting state, iterate through every character. We switch based on state, and we've commented our states here. We have no current token, processing integer, and then unrecognized state. All looks good there. And our final function or method to convert a code point to a string. All right, I think we're at a good commit point. Let's go come up with a commit message. Tokenize integers. Voila. Just kind of taking a step to think through what next here. We have kind of our target. Our initial target here is we want to be able to do, say, 12 plus 30. We've handled numbers, or integers. We've handled white space. We haven't handled the plus operator yet. Princess Rika just noticed this, chatted, I personally favor variations of my hands are typing words. Yeah, I mean, I'm sure we've all seen comments that look like, here, increment index. Well, gee, if I wouldn't have looked at the index plus plus, I wouldn't have known that I'm incrementing it. Comments like that are just pointless, and so, as Princess Rika would say, my hands are typing words is probably just as informative. Commenting is kind of one of those things that's tricky to get right. And so it's something for me that always kind of evolves. Oh yes, school code. Yeah, I'm basically in school when they're like, be sure to comment your code, and you have no idea what that means because you don't have enough experience to know how to write good comments. You tend to do stupid crap like increment index, set state to 1. It's like, why are we incrementing the index? Why are we setting the state to 1? Yeah, I've been there. I'm guilty as charged. Alright, for a plus sign, what we could do is if we're not processing a token, we could say, is it a digit? Otherwise, if it is I wonder if there's a way to get a plus sign dash punctuation, currency symbol, directionality. I don't see it here, but I think there is a class somewhere that does get you all of that. Just not sure. I can always hard code it. And maybe what we could do is add in, just temporarily, a plus code point, just so we have the code point here. I don't think I'll leave that in the full version, but just to be able to see what a plus sign looks like. 43. Which I wonder if I could do... So I got 2 code point with characters. Let's see here. Char count code point at. Code point count. Let's see, Java, compare code points to integers, or to characters. See, somebody suggested converting a character to an integer. Let's just try a couple things here. Let's say char c is equal to plus. Let's do cast to an int of, really? C. So we got our 43 as we would expect. The real question is if I give it an emote, does it recognize that? Huh, that's not quite what I expected my editor to do. Oh, come on. There we go. Princess Rika asks, do we have to parse emoji now? Closed character literal. Java illegal character. So apparently Java doesn't allow me to put a literal smiley face in my code. Let's see, I wonder if I could do a check like this. Let's say code point is equal to plus. Just to test this, we'll say plus sign. And it doesn't like those back ticks. Let's do regular ticks for these. It compiles, but does it work? Okay, so that'll work. What I wanted to avoid was putting integer magic numbers in my code for the plus sign, because that would just look crappy. Alright, so let's print out the fact that we got a plus sign. We also need to increment the index. And we'll keep our state at 0. So 1 plus 2 plus 3. Integer 1 plus integer 2 plus integer 3. Simple. Alright, sorry about that. I had to just step away for just 1 second. So pretty basic, and we can see how we could add in plus, minus, multiply, divide, all those different options. For now, our current target is to do 12 plus 30. That's our current target. And I think we're pretty much there. If we continue, we can do more larger stuff. 1, 2, 3, 4, 5, 6. And obviously, there's still... we don't handle A's yet. All right, let's get rid of this. We don't need this any longer. So integer 1, 2, 3 plus integer 4, 5, 6. Oh. Yeah, I want to fix this. I broke this a little bit in my haste to clean up my debug code. Really? It indented it for me. All right, so pretty basic change here. Let's go look at committing this. Tokenize plus signs. All right, so we have logic to do the tokenization for our kind of initial target here. You know, this 12 plus 30 is our initial target. But we don't actually convert this tokenization to a useful data structure. We just print it out to the... what's going on? We just print it out to standard out, which is fine for testing and debugging, but if we're actually going to do parsing and interpretation of this, we need to do something more than that. And this ideally should return like an array of tokens. And so just trying to think through what to do. What we could do is create like a token class and have different token classes for the different tokens. You know, we could have an integer token and a plus sign token, and just return a collection or a list of tokens from this function. So let's start with that. Let's create a new class. We'll call it token. Don't add it to Git right away because I want to do that myself. Let's add in the copyright notice. I know this is going to be annoying. This will probably be an abstract class. And I don't even think there's much to do with the base token, because basically this is just going to be a placeholder. What we need is to put in types of tokens. So let's add in a number token or an integer token. We'll start with that. New class, we'll say integer token. Don't add that either. This will extend token. Let's also add in our copyright notice for this guy. Ah, come on. This is going to have a private final value, integer value, int value. We'll have a simple constructor. We'll say this dot value is equal to value. And then an accessor. Public int get value. So really basic, but all this does is basically say, hey, we have a integer, and here is its value. These are probably complaining because these are never used. And then finally we'll have a plus token. This will also extend token. Let's go add in our copyright here. And this does nothing. So let's start to think through what tokenize is going to do. This is going to return a list of tokens. We'll just make it a linked list. It doesn't really matter. At the very end, we will return our tokens. So now, rather than printing out our tokens, we'll say tokens.add new plus token. And same here. We will say, instead of print out the integer, we'll say tokens.add new integer token. Actually, let's go back to what we had there just a second ago, just so I can steal this. We could say a list of tokens is equal to that. We could say for token inside tokens. Actually, let's do token inside that. I say token.toString. Now what we can do is add in a toString on these. Here's nice and basic. For integer token, we can do say integer plus I have to do this dot value when I'm referring to a member variable, just so we differentiate that between, say, parameter names and like function variables and whatnot. Yeah, so let's give that a try for the moment. That doesn't like something here. Oh, we're missing a parentheses. Alright, so we do 1, 2, 3, 4, 5, 3, 4, 5, whatever. Plus 79. Now notice we're not doing anything, we're not doing any checking on this weird formatting here. The fact that we have 2 plus signs in a row, is not something that's recognized by the grammar that we're working on, but we obviously haven't built the parser yet. We're just doing the tokenizer for now. So we have these lists of tokens. Let's go take a look at what this looks like. So we've added in these 3 files, token plus token and integer token. We've updated our tokenizer to actually return a list of them. So let's look at our tokenizer first. create a list of tokens. We initialize that to 0 or to empty. Rather than printing out the token, we add it to our list. Same with the integer. We'll return at the very end, and then we have our main loop basically iterates over those tokens and prints them out one by one. I'm just pausing for a second to see what's next. I think this is a decent commit point, so let's go ahead and commit this. Update tokenizer, or tokenize method to return a list of tokens. Princess Rika asks, what's that prefix notation doing there? Not sure what you're asking about specifically. You're asking about this or something else? This Lisp-like expression sticks a space in there. Yeah, this is actually an example of kind of a grammar. I already wrote a parser tokenizer for once. So it's kind of an example of an alternative language that I'm wanting to move away from. So this is not something I'm working on right at the moment. This is mostly just an example of work I've done before. Although I can see why I would have done that approach, because I'm beginning to think through what the parser is going to look like at this point, and it's definitely a little bit more challenging because, you know, let's go to our real expression here, just so we can start seeing what our real expression looks like. 12 plus 30. And so the nice thing with kind of the prefix notation is if we're looking at this, you know, I could see, oh, we have a open parentheses. That means this is going to be an expression. The first item in the list is going to be the operation performed on, and in this case, the plus operation. Then everything else, the 1 and the 2, is going to be parameters. And we keep reading parameters till we get to the close parenthesis. And so it made it nice and easy for processing things like that. And so what I need to do now, you know, my thing is I'm looking for this, and so, you know, I look at the number. You know, the first thing here is the number. And I can't just decide what to do based purely off the number. I need to actually keep looking and go, oh, here is a plus sign. So there should be something we're adding together. So this will be a little bit different for me in terms of parsing and interpreting. So I'm not sure how that'll work yet. And here we have our integer 12, the plus token, and the integer 30 is the tokens that we have. I just want to see if there's an example of programming language grammar. Short course in compilers. Yeah, I don't really want to go through that just yet, but yeah, here's the kind of expression I'm looking for. Expression could be an atom or a list. An atom is either a number or a symbol. A number is plus or minus 0 through 9. Symbol is Princess Rika says, you always know what you're doing, what you're looking for next, that sort of thing. I was just wondered what it had to do with this language. Yeah, just nothing going on here. Just I should probably delete it at this point, or maybe we could do just to clarify. Example language from past projects. And this is kind of the current work here. So I can start to kind of come up with expressions we can do here. You know, we have things like numbers, and while we have integers, well, I've already processed those. You know, an expression. How do they do that? They say is equal to why this could be an integer by itself. Yeah, let's just kind of come up with our own thing. The expression could also be a integer. What could be expression plus expression. Do we allow kind of nested expressions like that there? So I think this is kind of where we're at. Do we have, well, just some integers are kind of built in. Well, integer is equal to 1, 0, 0 through 9, one or more of those. Now we'll say plus is equal to the plus sign. So I think I could do like a recursive parser here, or a recursive evaluator, where I look at the list of stuff. And if I see an integer, well, it could be just this single integer of an expression. Or it could be this first part of this more elaborate setup here. So I would want to look one more to the right and go, well, is there a plus sign? And if there is, well, let's evaluate this, and then add, and then evaluate this, let's evaluate the left side, evaluate the right side, and then add them together would kind of be that approach. And of course, there's all sorts of things like operator precedence that we'd want to look at as well. Right now, we've simplified that since we're only doing the plus sign. Princess Rika, aren't languages fun? Oh, yes. Yeah, I remember why I would have done Lisp-like, because it removes a lot of this complexity, in that you basically know exactly what you're doing by looking at that first character. If we know it's a list. I sound convinced, yeah. And I kind of know what we could do with this. I mean, there's things on my mind for things I'd like to do with this language that are more elaborate. But until I kind of get some more experience with parsing and have some more structure in place, it's hard to do anything more elaborate than even the most basic stuff. But yeah, the Lisp processing is really simple compared to what I'm looking at here. Let's just start taking a look at what to do here. We have our tokenize function. Let's just start adding a private void evaluate, and we'll take a list of tokens. Princess Rika says, infix just makes everything okay. Now we try to find out what that thing is doing here. Yeah, it's probably going to be a bit of recursion, where I look at a list of something and then have to recurse to see what it truly is, and recurse and recurse and recurse until I get the actual thing we're looking for. We'll see. Let's see, let's just do something really simple here. Let's pull out the top token. Say token. This will break all sorts of stuff, but we'll do it for the moment. Is equal to tokens dot get 0. If token instance of, say, integer token, then we'll just evaluate this right away. Say system out.println. Oh, first I need to do this. We'll say integer token, integer we'll just cast that. Oh, why does it do that? So this is a very dumb parser. It only pulls out, or very dumb evaluator. It only pulls out the first item of that list. It doesn't even check for list length. Now let's actually call it here. Let's say main dot is this not coming up? Oh, we need to be private static. See what that does. Oh, it's already running. Well, let's stop and rerun. Where the heck is my mouse? So if we give it 5 by itself, we have our tokenizer, gets us integer of 5. We have results of 5 from our evaluator, and we can now evaluate a single number by itself. But if we do 12 plus 5, or 12 plus 4, well, we only get 12 because it doesn't handle the plus. So simple, but not quite done. And if we give it nothing, it complains. Just trying to think what this can return here. We can cheat and have this return a token. And let's actually go print out the result. We'll say system.out.println result plus that evaluation. And let's just return and we'll return null. So actually what we'll do is say throw so a nice generic evaluation error. Forgot what to throw in there as we need, but we'll start with that. So if I give it a number, we have 1 token. We evaluate that to the integer 1, 2, 3. If we give it 1, 2, 3 plus 4, 5, 6, still just evaluates to 1, 2, 3. If we give it plus 1, 2, we got our illegal state exception evaluation error, doesn't know how to handle a plus. And then the other error that we have is still present if I give it nothing. We have index out of bounds, index 0, size 0. So what we need to do is say if tokens dot length size is equal to 0, and return null. Result null. Excellent. So it handles the null case if you give it nothing. And handles 1, 2, 3. What it does not do is 12 plus 30. Let's see if this works without any white space. It should, but I don't think I've tested that. Excellent, that does work. All right, so what next? We've handled the case of no tokens. We return null. Then we get the first token. If it's an integer, we return it. Otherwise, we do evaluation error. And so what we need is if we encounter well, let's see. If it's an integer, we should probably have a more elaborate check here. So if tokens.size is greater than 1, so let's say if it's equal to 0, or sorry, equal to 1, then we know that we can just get away with returning the token. That's all we got. We have one integer, that's it, there's nothing else to process. Otherwise, we got to do something more complicated. And we could basically say, well, I think what I want to do is amend this to have like a left-hand side. Say token, let's call it the left token, the remaining tokens. And we'll have to fix this call here. The left case is null in this point. So what we can do is say return main.evaluate. The left token in this case is token. The remaining token tokens is tokens dot. So we've got sublist. Let's just look at the list interface and see what we can do here. I suspect it's sublist, but we will see what my options are. No form of add, not clear. Index of. I can't really remove because I don't want to I don't want to modify the existing list. Huh. Yeah, so sublist seems like it would be good. From index inclusive to index exclusive. If they're equal, it's empty. Yeah, so I'll say sublist. You want to go 1, comma, tokens dot size. Actually, we could simplify this a little bit further. We could get rid of the size check. Yeah, let's get rid of the size check. So if it's an integer token, we continue to evaluate. We pass in the left token now, which is the integer, and then we pass in the remainder of the list. Now this could be 0, or the remaining items in the list could be 0. And so what we gotta do here is, if the size is 0, we simply return the left token. We say there's nothing left to process, so let's just return what we got. And let's see what that does. It's not going to be complete, but we can test our basic cases and see what it does so far. So if I give it nothing, it should return nothing. If I give it 1, 2, 3, it returns 1, 2, 3. If I give it 12 plus 30, we should get an error. So we count on the 12, we pass the 12 in as a left token, and then pass plus and 30 as the remainder here. And we don't handle the plus, so let's handle the plus. So if token instance of plus token. So now we basically we have our left token, and then we need to get our right token at this point. So we can do token right is equal to main.evaluate. There is no left token at this point, so we'll say null. And then it'll be this. So now we're going to have left token and right token. And we need to add them together. So we need to do things like, if left token not instance of integer. I guess it wants me to wrap this in parentheses. If that is not an integer, or if right token is not instance of an integer, cannot add let's see here. Let's give it some formatting. We'll say plus left token dot toString plus right bracket and We'll give it the same thing for the right token. Editor just trying to be too smart. Otherwise, we can say integer token left integer is equal to integer token, and do the same thing for right integer. Then return new integer token to be left integer dot get value plus right integer dot get value. We'll change this to say unrecognized token. See what this does. So if I say 1 plus plus, you have null pointer exception. Okay, that's not fantastic. Null pointer exception, line 136. I wonder if we can just get rid of the two strings. One plus plus. Cannot add null and null. So the message is a little weird, but probably what's happening is, let's see here. We encounter an integer, so we put the integer on the left, and then evaluate the rest, which is plus plus. So we encounter a plus token. So now we evaluate the right. We pass in a null, and the remainder of the list, which is another plus. Oh yeah, somebody highlights. Princess Rika mentions I have a mistake here. This should be right token, left token, right token. Good catch. Let's try this again. I suspect the error might still be correct, but we'll see what we get here. Yeah, I can't add null, null. So we encounter the first plus. We pass in null to the left, and then the plus is passed in. So then we hit the second plus, we have null for the left, and an empty string. We process that. The empty list returns null, or returns left token, which is null. Princess Rika says, oh, that's not the issue, of course. You're working on your own project. Oh, no worries, I know it wasn't the issue, but it was certainly an issue. The issue is that I think it's working correctly. It's just we don't have really good error reporting yet. We don't have good context, and so I think the error is still correct in that it is truly null and null. Let's actually try with a correct bit of logic here and see what we get. We'll say 1 plus 2. And here we actually get a result of 3. And that's great. Let's try 1 plus 2 plus 3. a result of 6. So I think we have a parser, an interpreter that can handle a simple expression to add as many numbers as we want together. We could probably do a very elaborate version here. Let's try our test target, the 12 plus 30, just so we can make sure that works. Result is 42. The ultimate answer to the ultimate question. Let's make a more elaborate test here. Added the numbers from 1 to 9. 45. And yeah, that looks correct. Now if I give it a plus, cannot add null and null. This doesn't make a whole lot of sense yet. It'll make a little more sense when we start adding in other types. Right now we've only added in the concept of an integer type, but if we add in, like, say, strings, then we'll decide how do we handle addition of strings. And certainly one approach is to force casting and throw an exception if you attempt to add a string to something else, to an integer, say. But for now, I think this is a pretty basic approach. The code is pretty jammed up. Let's see if we can kind of clean up the code a little bit here. Just kind of thinking through what to do here. Let's go look at our Git status here. So we've added this call to our evaluate function. We pass in null for the left-hand side, or the left token, then a list of tokens to evaluate. If the token's size is 0, so we pass in no tokens, we simply return the left token. This is kind of a shorthand to handle things like the plus token. Actually, no, it's for evaluating integers. So if, like, we evaluate an integer, we want to pass in that integer itself as the left-hand side, and then evaluate the rest to see what we encounter. And so the hope is that if we encounter a plus, well, let's evaluate the left side, which is the integer, and then evaluate the right side. And so it's janky, but it works for this special case here, this very simple case. As we continue to add in more elaborate logic here, we'll need to think about this, particularly if we start adding in, say, multiplication, division, modulo. There's going to be operator precedents that we'll have to consider that I'm kind of ignoring just for the moment. Now, it could be really mean and don't handle operator precedents correctly at all and simply say, you know what, we're going to basically process the first operator we see and force the developer to use parentheses to establish precedents, if that's something they want to use. I think I would prefer to handle precedents properly, operator precedents properly. The result of this was 45. We had done some testing. Princess Rika says, "Bahaha, make the user do it. That's the way." Certainly an option. Now let's just look up. Let's see how Java does. We have Java, operator, precedence. Princess Rika says, "Excuse me, your maths are broken." Nope. User error, not my problem. Yep, look at the language definition. Language definition says it's user's problem. The higher precedence goes first. For example, 1 plus 2 times 3 is treated as 1 plus 2 times 3. Expression has two operators with the same precedent or precedence. The expression is evaluated according to its associativity. For example, x equals y equals z equals 17 is treated as x equals y equals z equals 17, leaving all three variables with the value 17. This equal operator is right to left associativity, and assignment statement evaluates to the value on the right-hand side. On the other hand, 72 divided by 2 divided by 3 is treated as 72 divided by 2 divided by 3. Since the division operator is left to right associativity, yeah, this is what I do. Most programmers do not memorize them all, and even those that do, you still use parentheses for clarity. That's my thing. If I have an expression that's complicated enough, I will still use parentheses just to make it clear what's going on. And only if I really have something I really want to make compact will I rely on the precedence. So it looks like level 16 is the highest level. We have square brackets, access to object members and parentheses are the highest precedence. Then we have post-decrement, post-decrement, pre-increment, pre-decrement, plus, minus, not, casting, object creation, multiplication, division, modulo, addition, concatenation, shifting. I doubt I will add all of these operators. I'll just add the ones that I feel like or that I need for my work. Probably started with the basics. I already have plus, and I'll probably add minus. And I'll want to add multiply, divide, and potentially modulo. We'll see how that works. Yeah, so I think let's use this as an example of precedence. Let's pull out my notes here. I'll keep that notes of precedence handy. Kind of thinking through what's next here. So we've been working on our main loop. We read from standard in, we process what is typed, we print out the result. And so we have some basic logic already. Let's go review what we have going on. So if I type nothing, I give it the empty string, it returns null. We'll decide what to do with that, but for now, null seems to make sense. So if we give it a number by itself, 12, we have our tokenizer, and our result returns 12. We have some cleanup we could do. We actually print out the... we print out the list of tokens, and then we print out the result, and then we print out the line that was typed in. We don't need to dump all that, so I think I might do a couple of passes in terms of getting rid of unneeded output. Then we have our kind of example case here, this 12 plus 30. Let's give that a try. We have our output for all of the different tokens. Integer 12 plus integer 30, or result integer 42. Then the line we typed in. Then we have our more elaborate test case here. Yeah, so I think we're at a good commit point. Let's just see where we're at. Add evaluation of integers and plus signs. And yeah, I think at this point we could start to get rid of some of this excess output. For example, I don't think we necessarily need to print out the line. And I don't think we really need to print out the tokens any longer. If we have more debugging, we can always print out, we can always add that back, but I think we'll just get rid of that for the moment. Try our 2 test cases. Yeah, so we got our result. And that's it. We don't get anything else. We don't need that. So I think that's pretty good. Yeah. Status. This is just removing debug output. Go crash that. There we go. Alright, so going back to our main loop, we read from standard in, we process what is typed, we print out the result. That is working for the moment. Things we're missing. Plus, we'll see, we have minus operation, minus operator, multiplication. Let's just make a whole operators section here. Operators. Those are kind of the basics. Probably want to add in parentheses. Variables seem like they're handy. At some point, we're probably going to want to have expression termination. Because if we actually look at some of our more elaborate stuff here, if we declare a variable, declare another variable, and then do this, we'll need to have some way of delineating expressions. We've been using semicolons, which we have not done anything with semicolons yet. We can certainly see at some point we'll need to deal with expression termination. We'll need to think about methods. And so yeah, all this will kind of slowly begin to add in more and more complexity, more work to our parser, more work to our evaluator. And at some point, my hope is to add in, start working on the version of this interpreter built into the interpreter itself. And so we'll need to start adding enough logic to rewrite this code in terms of the language we're building. So I don't have a ton of code here yet. Princess Rika says, feature creep! Who needs trinkets like variables anyways? Well, that's a good question, because when I did the Lisp variant of this, we did not have variables. It was purely functional. And it made things a lot easier because we didn't have to assign things well, I think we may have added variables at one point. I forget. I think I may have added variables at one point because I needed them for something. But I think for a good long while I didn't have variables. We have method declarations. Method calls. Oh, variables, we have things like variable declaration, variable assignment, variable references. Probably do those all at once, but kind of different elements there. Method declarations will have methods, or functions. We'll call them functions. Because methods are really more of an object-oriented thing, and I'm not really intending to do an object-oriented language here. But we'll see. Let's see where we're at. I think everything's committed at this point. I'm going to go ahead and push this off to Git, or to GitHub. For those of you following along at home, if you want to look at this code, you have access to it through my GitHub repository. GitHub.com/cutepixel/Noble is the name of the project. I'm going to go see if my stream elements command works here yet. No, it's still not working, but I can still paste in the URL there. I'll have to check that off stream and see what's going on with stream elements. I'm not sure why it's not recognizing that custom command I've added. Maybe it's not liking the URL, I'm not sure. Princess Rika says, maybe you should make a bot too. I actually have built a Twitch bot in the past. It's not hard to make a very simple bot. I actually used, was it TMI? I think it was. Yeah, I built a TMI app using Node.js. I was basically doing something that would log events in a channel. So log things like actions and messages and stuff like that. It wasn't hard, just tedious. I found that TMI hasn't been completely updated for the newest stuff. So there's like events here for subscriptions, I believe. Yeah, you get a username has subscribed to the channel, but it doesn't have an event for like a gift subscription. Princess Ricky says, I made one too, it was just easy. No, I think it's a decent project. I mean, one of my thoughts for a project to do in the future is to build like a Twitch Plays type application where viewers would be able to interact with the app by chatting in the channel and do things on stream. And so certainly I want to look at something like this again. I'm considering what technology I will use to do that. Since I want to get into Unity, I'll probably be looking at doing a bot in Unity or something that Unity can talk to. But until I get more familiar with Unity, it's going to be tough to do that. But all sorts of fun stuff there. Alright, well for me it's about 12:30 in the afternoon my time. I haven't had lunch yet. And I think I'm at a pretty good stopping point. We've made pretty good progress today. We've created the initial version of the project. We've added Hello World, and then we've moved on top of that. We've added our initial kind of logic to read lines from standard input or write them to standard out, our kind of basic in-out logic loop. We've added a basic tokenizer that can tokenize integers and plus signs. And then we've added evaluation of integers and plus signs. So you can actually grab this yourself. You can clone the repository, run Maven package to run it, or to compile it. If you give it nothing, it returns null. You can give it a number, or a number plus something. If you give it something it doesn't recognize, it'll complain and crash. Same with A's, B's. Boo, more code stream. I know, I'm sorry. Just... I'm kind of running out of energy for today. I know I kind of did like a 6-hour stream last week. Lunch is inferior to coding. Like, developer need food badly. And I got a few other things I got to take care of. I think we're at a pretty good point here. I think let me bring up my schedule so you guys can see when I will be streaming next. Today I've been working on the interpreter for custom language. Next week is my next stream, Sunday, January 20th at 9 a.m. will be my next stream, continuing open source software development. Unless something changes, I will likely be continuing work on my interpreter for my custom language. And I'll think a bit more about your projects to do with that and whatnot. Also off-stream, going to continue to work on Unity and hopefully get into more game development. So at some point, you will see actual game development with Unity on my channel at some point here. Can't promise when that'll be yet. Still a little bit off. Yeah, so let me just make sure this all showed up. Yeah, there it is. Remove debug output. There it is. Alright guys, well thank you for tuning in. It is lunchtime for me, so I will see you guys next Sunday at 9 a.m. A week, that's like forever. I know. My schedule is really tight at the moment. It's tough to fit a bunch of streaming time in. I'm trying to fix that. But right now my commitment is to do at least every Sunday morning is my current objective, and if I have time, if I have a chance, I will add in more stream time. But Sunday mornings is kind of what I have working right at the moment, and I will add in more time as I can. I do thank you for checking me out, and I will catch you guys next time.